Welcome to Engineer Explains. This is part 2 of our Algebraic course. So in this video, we will be learning algebraic addition and simplifying of expressions. Okay, and so in our previous video, we already introduced what algebra really is and how it is useful in real life. And so in this video, we will be introducing adding numbers versus adding algebra. So what you already know in our previous video, this is an arithmetic expression, and an expression is just a statement without an equal sign. So if this is an arithmetic expression, what do I mean by that? It is just the addition of numbers with, well, okay, it's not an expression, I'm sorry, because we have an equal sign here. So it is an arithmetic equation. Just like I said, an expression does not have an equal sign, but an equation does have an equal sign. Presence of an equal sign. Okay, so now let us introduce what is algebra. So algebra here, it is still the same as the arithmetic, just that now we have unknown numbers here. Okay, so we introduce these as coefficients, and here it is also a coefficient. Yes, so these are unknown numbers or variables. Okay, so that is basically algebra that we're going to be focusing on today. We are going to be adding these numbers, or adding in algebra. So it is one of the same thing, just that now in algebra you have an unknown. Okay, question. Now, can we add this? So that is the question you have to start with. Whenever you see an algebraic expression, can you add this? So you might be given something like 3x plus 5y. So if this is a final expression, you must leave it like this. Okay, but now if you have 3x plus 2x, that is equals to 5x. So what changed here? You must know that in these unknowns, these are the same quantities. And what do I mean by the same quantities? Well, a quantity represents a, let's say you have 2 apples, right? And Johnny has 3 oranges. In total, yes, you do have 5 fruits in total, but in total you have 2 apples and Johnny has 3 oranges, right? So now we call that the fruits analogy. The fruits analogy. Okay, the fruits analogy says if we have the same fruit, we can add. Same fruit, you add. Different fruits, you leave them like that. Okay, different fruits, you leave the expression like that. Okay, leave the expression as it is. Okay, so if now we have this understanding, we can go to understanding the terms that we are going to be working with. So before adding, you identify the terms. So this is a term, this is also another term. Okay, and so in this expression we have 2 terms. Okay, 2 terms, and you have to understand them clearly. So for example, let's say you have 3x squared plus 2x plus 5. Okay, so here you have this first term, right? This second term and this third term. In this first term, you have x. Yes, this x here is the same as this x right here, right? So these are the same quantities, but now they are in different groups. Let me say groups. Okay, So what I mean by that is that, let's say for this x right here, it is in a box. Okay, this box right here. And this x right here is just the apple. Okay, it is just the apple. So you have two apples in this case, but for the squared now, it is the square. Okay, that is making this difference. That is why I put it in a box. You have more than one or two here in this instance. We do not know the total. That is why I'm just writing in random, because we do not know the total that is in here. And so these two right here, they do not add. Okay, do not add. Do not add. Yeah, they do not add, although they are the same fruits, but they do not add due to this exponent right here. We introduced this in our previous video. So yes, we have three terms, right? Same as for this 5. This is a different quantity as well. This is just a constant in this expression. So this is just going to remain as 5. And so the final answer to this will be 3x squared plus 2x plus 5. And you leave it like that. Okay. So even in this, let's go back to this example. You have 4x plus 7. Okay. So the terms are 4x and 7, and you leave it like that. You identify the terms you are working with. Okay, let's move on. So example number 2, you have 3x plus 5y plus 2. So identify the terms that you are working with. Remember what we said about the fruits. If you have the same fruits, you add them, but if they are different fruits, you do not add them. And if they are fruits of different groups, you do not add them as well. Okay. So you have 3x here, 5y, and a 2. So this is working with x's, this is working with y, and this is a constant. Okay. We do not add this. Yes, we have 3 terms here, by the way. You must know them all. Okay. And if you cannot reduce the terms, you leave it like that, and your final answer will be 3x plus 5y plus 2. So these are the terms that are in this expression. A term is separated by addition or subtraction sign. Okay. So in this instance, you have the addition right here. So now what happens if we have like terms? So like terms are terms that have the same variable raised to the same power. Okay. So let's go back to the example I made, 3x plus 5x plus 2. In this example, I said, if now we have a square, but this one is raised to the power of 1, there is an invisible 1 over here. It is always raised to the power of 1 when it is not shown. Okay. So if now we have 5x and we have 3x squared, these do not add. Remember that. Do not add. Even if you have 3x to the power of 3, do not add. Okay. Do not add. Please, I just like to make that distinction. We do not add the following. Thank you. Please do not ever make that mistake of adding these quantities or terms, if you would like to use that word. So here in this example here, you have 3x and 7x. So let me just write 3x plus 7x. So this is our example. These are called like terms and you add them together. Okay. 3x plus 7x makes who? Because they have the same powers. Okay. They are raised to the same power, so you can add them. 3x plus 7x makes 10x. So if you had 3x squared plus 7x squared, that would be equals to 10x squared. They are raised to the same power. Okay, same power, you add them. But now if you had 3x squared plus 2x this would be just, oh sorry, why am I adding this now? This would be equals to 3x squared plus 2x, and this would be your final answer. You would leave it exactly like this. Why do you leave it like this? They have different powers. This is raised to the power of 1. Remember that, okay? And so let's make another example. So let's say we had 3x to the power of 7 plus 2x. So remember, this is raised to the power of 1, okay? This 2x is raised to the power of 1. And so let's not make the mistake of adding things that have the same, that have different powers. So in this 3x to the power of 7, you would leave it as 3x to the power of 7, and this would be 2x. And you would leave it exactly like this. There's nothing to add here, okay? Please never make that mistake. And so here we're talking about like terms. In this expression, we had 3x plus 7x, which made 10x. We are certain now that they add. Why? Because they both contain x to the exponent of 1. Okay, therefore 3x plus 7x is equal to 10x. Thank you. Here's another one. Let's say we had 5x squared plus 2x squared. These two, like I explained in the previous example, 5x squared plus 2x squared. Now notice here, they have the same what exponents. They are raised to the same exponent, which is 2 or cube. 5x plus 2x, they would add up to 7x squared. Okay, yes, exactly, just like they added here, 7x squared. Thank you. And so now, like I explained in the previous examples as well, now we are just explaining in the professional terms which is used in textbooks. So now they're using the word unlike terms. These are different variables that cannot combine. For example, 3x plus 5y. I said in the previous example, we had 3 apples plus 5 oranges. They do not add. Okay, they do not add. Do not add these. You cannot add 3 apples and 5 oranges and say now you have 8 fruits. No, we want the name of the fruits as an answer, and so our expression is final like this. This is final, okay? You do not add this. This is final. You do not add. So this is a different fruit from this one. So this x and this y are different fruits. Do not add them, okay? Different fruits, you do not add. I emphasize this. Thank you. So x and y represents different quantities. This is like saying 3 apples plus 5 oranges. You have 8 pieces of fruit, yes, but you do not have 8 apples or 8 oranges. Therefore, 3x plus 5y stays as 3x plus 5y. Thank you. So the rule for adding algebraic terms. Step 1, you identify the like terms like we did in our examples where we had 3x plus 2x. So these are like terms, okay? Like terms. Why? Because they are raised to the same exponent, okay? Like. And so if they are unlike, you would have 3x squared plus 2x. This is unlike. Unlike. They do not add. And here they add. Okay? Do not add. Thank you. So you identify the like terms first. Step number 2, you add the coefficients. the coefficients are 3 here and this 2 right here. And so if you had 3 apples and Johnny had 2 apples, in total, how many apples do you all have? You have 5 apples. So you guys, you carry the coefficients, okay? You are carrying the coefficient, okay? Thank you. Add the coefficients. This goes also for subtraction as well. If I had 3 apples and we ate 2 apples, we would be left with 1 apple. So this is just represented as x, okay? Do not write the 1, it is invisible in mathematics. But you know that there is a 1 here, it is always there, okay? And so add the coefficients but keep the variables unchanged. Do not change the variables. Here in this example we established here, we said 3x plus 2x, and so this variable had an exponent of 1, so the answer here was 5x. Excuse me. The exponent remained 1. The exponent remains as 1. Do not change exponent in addition, okay? Do not change the exponent in addition or subtraction. Do not. I repeat, do not change the exponent, okay? Do not change the exponent in addition or subtraction. We will introduce the changing of exponents in multiplication and division. And so here, let's make an example. Example number 1. Example number 1 here, it is 4x plus 6x. And so you remember the steps. Identify the like terms. Like terms have what? They have the same exponent. So this is 4x to the power of 1 and 6x to the power of 1. And so they add. You add the coefficient, which is 4 and 6. 4 plus 6 is what? It makes 10. Okay, so 4 plus 6 is 10. And so when you have added the coefficients, then you write the x. Okay, then you write the x. Add the coefficients and write the x. So just remember, like terms, you add. Yes, you add. Step 2, add the coefficients. 4 plus 6 is 10. Step number 3, you keep the x, okay, which is 10x, right? So that is basically algebra, okay? You get it now. I hope you get it. And if you don't, you can rewind the video. Example number 2. Let's say now we have 8 apples plus 3 apples plus 5 apples. Remember, we're not always going to have an x here. You can use different letters. Remember, the letters represent the unknown values. Okay, the letters represent the unknown values. Thank you. So 8 plus 3 is how much? 8 plus 3 is 11, and 11 plus 5 is 16. So you can identify the terms. The terms here, that they are all like terms, okay? They're all with a variable of a. They all have a as their variables. And so you add the coefficients. 8 plus 3 plus 5 is 16. And so the answer is 16a, okay? So now let's add multiple variables. Let's remember our steps. Step number 1, identify the like terms. So here, 3x, 7x, these are like terms. And 4y and 2y, these are like terms. The ones that do not have the arrows connecting each other are unlike terms, okay? And so you add the like terms, or in professional mathematics, you group the similar terms. 3x plus 7x and 4y plus 2y. Okay, and so you add them. So what is 3 plus 7, which makes 10x, and 4y plus 2y makes 6y. Okay, so the order does not matter. This is the commutative property. Commutative property just means the order of the variables does not matter as long as you add them. So even if you had 3x plus 17y plus 5x minus 3y. So here it says commutative property. You can add these even though they're distant to each other. All you have to know is the symbol before the coefficient. Okay, so this is a positive 5, and so it is 3 plus 5. Okay, so that would make 8x, and 17y minus that 3y. All you have to know is the sign of the coefficient, and so 17y minus 3y. So that is 17 minus 3. 17 minus 3 is basically 14y. Okay, the answer is positive. Okay, the answer is a positive 14, but 17 minus 3 makes a positive 14. So this will be your final answer. Okay, it is the commutative property. It means you can basically add or subtract in any order, even if you had a large expression. Okay, and so here a few practice questions. Question number 1, let us simplify. Okay, so we are given this expression 5x plus 8x. So first step is to identify the like terms. So are they like terms? Yes. Why? They have the same exponents. Okay, and so you can add 5 plus 8 makes I think 13, right? Yes, 13x. Okay, then you write the x next to the numbers. Question number 2, simplify this expression. 4a plus 7b plus 3a. Identify, number 1, you identify the like terms. Here's a, here's another a. Do they have the same exponents? Yes, this is a to the power of 1 and a to the power of 1. Okay, so you add these like terms. These are like terms. Okay, you group them if you want to, or you can just add these, but for beginners I would like for you to group them like this. Okay, 4a plus 3a, and then you add the 7b, which is just the remaining. Okay, and here's your answer, 7a plus 7b. Question number 3, you simplify the following expression. Remember, now if you have similar quantities, but now they are raised to different exponents. Okay, these are all different quantities. These are all different how can I say this? Yes, they are the same fruits, but now they have different exponents. So they do not add. Okay, do not add different exponents. Okay, so let's group the like terms and leave this one alone because it is the only one with an exponent of 1. 2x squared plus 5x squared. 2 plus 5 is basically 7x squared, and this 3x on its own is like this. And so this is our final answer. Okay, I hope you enjoyed today's lesson. Please like and subscribe the video, and we'll be back for part 3, which is subtraction of algebraic expressions. Thank you.